Hello and welcome to the Geogebra tutorial. My name is Chirag, and in this tutorial we are going to talk about the sliders. So basically sliders are nothing but free flowing numbers that you can select from the menu bar. You click on sliders and have a name being added to a slider. For example, like we have a slider with name A, which takes in the minimum value of -5, maximum value of 5, and we can set the incremental value to 0.5. So that means this value or the slider A will take values from -5 to 5 in the incremental loads or increments of zero point 0.5 units. As we click on OK and move the slider takes in different values of A in the increments or decrements of zero point 0.5 units. So basically, like suppose if I want to plot the line with by using these two sliders. So for example, I want to plot a line y is equal to ax plus b. So depending on the values of a and b, the definition of the function will be changed. So in this case, I change the value of a to 1, and let's change the value of b to 3. So we can see that the equation of the line is 1x plus 3. So the benefit that we are getting over here is, as we change the value of a and b, the line or the definition of the line changes. Otherwise, the other option would have been to change the definition of the function every time. So what we have done is we have introduced a free flowing value a, b. We control the variables from outside, and that changes the definition of the function. So this is a very good feature available in GeoGebra, that we can make use of sliders and changing the definition of the functions. So let's take an example of the general sine function. The general sine function is given by y is equal to a sine b out x minus c plus d, where a is the amplitude, b affects the period, c affects the horizontal translation, and d affects the vertical translation. So what I'll do is I'll hide the line. I will add two more sliders, one for C and the other for D, and I will add the general sine function y is equal to a out sine b x minus c plus d. So as you can see, like as we change the values of a, b, c and d, the definition of the sine function changes. So I just restore it to the defaults. So as we can see that the sine function is, the function g is defined as 1 sine 1x, which is same as sine x. And let's learn about the transformation of functions. So basically a affects the amplitude of the sine curve. In the other terms, like a represents the vertical stretch or shrink that will happen based on the value of a. So as we can see that if I go ahead and change the value of a, if I increase the value of a, we see a vertical stretch in the function. And similarly, if I reduce the value of a, there is a shrink in the vertical direction. Next we have is the factor b that affects the period of the function, or in other words, the factor that causes a horizontal shrink or stretch. Okay, so we have a is equal to 1. We'll take it to the default values, and as we can see, if I change the value of b, there is a vertical shrink or stretch that happens. Okay, so we can learn about the transformation of functions very easily by using the sliders. Next is the factor c that affects the horizontal translation. So c affects the horizontal translation, so we'll move the value of b to its default value. C affects the horizontal translation, which means that the function will either move to the left or right depending on the value of c. So if I increase the value of c, if I make it 1, that changes the definition of the original function, and that's the plot of y is equal to sine x minus 1. I can even change it to a value, let's say I can change it to a value pi. So to type in the value of pi, I just need to type in pi, and that takes in the value of pi. So we can see that the sine function has moved to the right by pi units. So this is the, we can see that C affects the horizontal translation, the shift to the left or right. And then finally we have the factor D that affects the vertical translation. So if I change the value of D, I see that the function goes up or down, like there is a movement in the vertical direction. So the factor D affects the vertical translation of the function. Now, one more thing that we can learn about, or there's one more property that we need to know, is that in sliders we can have something known as animation. So basically, if I want to see or learn that how does the value of D affect uh, the nature or the behavior of the sine function, the original function G. So in that case, what I can do is I can right click and say that I want an animation on of speed 1 unit, and the repetition pattern will be oscillating, moving from -5 to 5 and from 5 to -5 once again. And once I click on animation on, we can see that the value of D changes, and the change in the value of D also affects the original function. Now I can change the pattern in which the values are being changed. So basically I can change the repeating pattern from oscillating to have only increasing. So if I change it to only increasing, you can see that after reaching the maximum value of 5 units, it goes back to -5 and it keeps on in the incremental format. All I can do is I can change the repeating pattern to decreasing, where the value of D will always decrement. After reaching the minimum value, it will go to the maximum value and it will decrease once again. Or the last option that we have is increasing only once. So just the value of D will increase by once, reach the maximum value, and it will stop over there. I can even change the speed in which I want the animation to be seen. So right click and say animation on. So as you can see that the speed of animation has increased. So these are some of the features associated to the sliders. There's one last thing that I want to talk about in sliders, where we can trace the different values which are being chosen by the function. So what I'll do is I will select two sliders A and B, define a line in the form of y is equal to ax plus b. Once I select the line, now basically what I want to do is I want to study the different values which is being traced by the function as I, let's say, change the value of b. So if I change the value of b, I want to see what all are the different values which are being taken by the function. So for that, what I'll do is on the function, I will go and say trace on the value of b, I will start the animation. So basically the point is that if the value of b changes, what are the different values that the function will take, and in this case the trace is set to on. So that means that the function, all the values which are being taken, or all the graphs will be shown of the function on the graph. So if I click on animation on, we can see that all the values which are being taken by the line are seen in the graph when I keep the trace on. So as you can see that it fluctuates in between -5 to 5, because that is the limit in which we have set, and all are the lines that we see are the trace of the function f as we change the value of b. I can even change and add the animation on for a. So that means now this time the slope also changes along with the y-intercepts. So we can see a variety of patterns, and maybe we can learn about how do 2 or 3 factors affect the function, the graphs of function, and how does the function behave. And just to clear out this the entire design or the pattern, you can just move the view window and it starts altogether fresh with the incremental the changes in the values of the sliders. So just to summarize, what we have learned so far is sliders are free flowing numbers. It can be of great use rather than retyping the equation again and again. You can just introduce a slider that acts as a variable. You just change that value, and the let's say the coefficient and the constants keep changing. You get the different definition of the functions, and you can learn about the change in one parameter and how does that affect the graph of the function. Thanks for watching, and we'll learn few more features associated, few more features in GeoGebra. So keep watching. Thank you.